off before lunch is we were graphing these points. Hello? All right, here we go. So I ask you to take and plot these points. Okay? So let's discuss this. So we're doing absolute value of f of x. All right. So one way we do this, we're actually making a table and doing all that, or we can shortcut it. We'll look at another way. And so if we were to do this, -4, 0, -3, 1, -2, 0, -1, 1, 0, 0, 1, 1, 2, 0, 3, 1, and 4, 0. All right? So if we were to do that, there's where those points go. So I have this, and have this, got this, got this. So there is what you should have graphed. All right? Now, what do you notice about that graph? We kind of talked a little bit on the other activity earlier. All right? What do you notice about the absolute value here? It's only positives, so we only have a positive graph. And so if we were to name our range here, our range is all only positive values. All right? Could we have graphed this without having to do all the table? What happened to our positive values? They stayed the same. So this part of the graph right there, this part of the graph right there, it stayed the same. But the negatives reflected. The negatives went up and reflected. Okay? So here's what I'd like for you to do. All right? The next part, I'm going to help get you started a little bit on this, but then I want you to go graph this. We're going to go fill in the third column. All right? So if we were to do this, I'm going to do the very top point, I'm going to do the very bottom point in this for you, and I'm going to let you fill in. All right? If I did 4, if I did the bottom value, if I put 4 into here, it stays the same. It's still 4. So if I put 4 in, it looks exactly the same. And so when I have a 4, I have a 0. So that would be there. All right? If I plug a -4 in, if I plug a -4 in, it's going to turn into a +4, and it's going to look just like this 4, and so I'm going to take that y value. Now you're saying, well, they're the same. In this case, they are. Okay? Well, let's talk about the 3. If I took 3, plug 3 in, it's still going to be 3. The y value is -1. If I take -3 and I plug in, it's going to become +3. So it's going to take the y value of the +3. So this one's going to be -1 as well. All right? So what I'd like for you to do is finish plugging in the table and then go take that and go graph that one. Okay? So finish plugging into the table, take that and go graph. Alright, so let's finish. Alright, so what do you notice about all the ones down here on the bottom part of the table? What's going to happen with all the ones on the bottom part of the table? Are those the easy ones in this case?
Yes.
They are the easy ones because all these x's right here are going to remain positive, which means the y's are going to be matching. So this would be 0, that would be 1, that would be 0. So they match exactly there. Okay? The ones that are going to change are these negative x's are now going to turn positive. Okay? So these negative x's are now going to act like the positive x's. So this -1 right here, it says it's -1, but it's not going to act that way. It's going to act like the positive one, and it's going to be there. Okay? So -1 is going to be that. Now the -2 is easy, it's 0. Okay? Now, if you were to go graph this, if I were to graph these points, I've got -4, 0. I've got -3, -1. -2, 0. -1, 1. And so on this side, it looks like this. And then the next one would be 1, 2, 0, 3, -1, and it would look like this. So there is the graph for the second one. There is y equals f of absolute value of x. Okay? Looks a little bit different. All right? On it, what stayed the same on this graph? This entire right side stayed the same because those were my positive x's. My positive x's, when I do the absolute value of positive x, it doesn't change. So this whole side stayed the same. What happened to the other side? Basically disappeared. All the negative y values disappeared. All these negatives over here are going to look exactly like the positives here. So how did it flip? It reflected over the y-axis. Okay? So what I'd like for you to do at the bottom of the page, we talked a little bit about it last Friday. We talked a little bit on Monday. But I want you to describe the similarities and the differences between those two graphs that we just did. So give me about a 2-sentence statement at the bottom of the page. Describe the similarities and the differences when we're graphing f of x, absolute value of f of x, and absolute value of f of, excuse me, and the f of the absolute value of x. All right? Write me a little sentence at the bottom of the page. And I have a couple little statements there. All right. So what's going to take place if you had to describe this one right here? The absolute value of f of x. How would you describe that? What's going on there? Say again. Okay, we're going to only have positive y values. How would you graph that transformation? What's that going to do? Say again? Did I spell only? I sure did. Thank you. There you go. So I'm only going to have positive y values. All right? The transformation that we see in there is there's a reflection. Where's the reflection? Over the x-axis. Now, does everything get reflected over the x-axis? No. And so some of the graph stays the same. scroll up just a little bit so I got a little bit more room to write. All right. Some of the graph stays the same. And the negative y values reflect over the x-axis. Okay? So we see a reflection here, but we don't see a complete reflection of everything. Okay? So could we make a very similar statement for the f of the absolute value of x? What happens there? Which way are we reflecting there? We're reflecting across the y values. So the positive x values stay the same. The negative x values are a reflection over the y-axis. Okay? So with these absolute values, we're seeing a lot of reflections, but it's not a complete reflection. All right? Not everything. It's that idea that absolute value, the positives stay positive, but the negatives turn positive. So some things are changing, but some things are not. Okay. So hopefully this little activity here gave us another little chance to look at these absolute values. All right, we're going to do a few more as we're continuing as well. All right, but I want you to see that. So here's what I'd like for you to do. Take the graph paper that you have. All right, so I gave you a blank sheet of graph paper. And on one side of that, I don't care which side you pick, it's the same on either side. Come on. Okay. Anybody need one? All right. And I'm going to give you an equation. I want you to tell me the transformations, and I want you to graph it. So this is not connected to the activity that we did at the beginning of the day or on Monday. This is a separate deal. So here's what I have. I have f of x equals x plus 2 minus 3. Okay? So this is a standalone graph. This is f of x equals absolute value of x plus 2 minus 3. What I'd like for you to do is I would like for you to tell me the transformations, and then I'd like for you to sketch me that graph. This is not a piecewise function. I don't think we're using that. I'm sorry, no, I wouldn't. All right. Make sure we're graphing. It shouldn't take very long. Name the transformations, then draw me a picture of that graph. All right. Transformation. Somebody give me a transformation we see. Down 3. Down 3. Okay. What else? Left 2. All right. What is the shape of this graph? It is a V. Absolute values have a shape of V. it's normally at 0, 0. The vertex would be. But it's been moved how? Down 3 and left 2. So there's my vertex. Okay? What is the pattern for an absolute value graph? 1, 1, 2, 2, 3, 3. All right, it's moving with a slope of 1. 1, 1, 2, 2, 3, 3. And so here's that graph. Okay, so that's all I wanted you to do on that one. We'll come back, we're going to use that again here in a second. Okay? Everybody okay on that one? Okay? On another graph, same page. Pick a different graph now. All right? I want you to go graph this right here. I'll put up on their board. All right? I want you to go graph g of x. G of x is going to be 1/2 x plus 3. So I want you to go graph that one. As you're doing this, I'd like for you to name me the transformations that are in this as well. See if you can name me the transformations that go with this. This is a little bit easier graph. We'll see if you can name the transformations. This should be a lot easier graph, correct? What is this a graph of? A line. How do we graph a line that's in y equals mx plus b form? That's all that is. We're going to start y-intercept at 3. And we're going to do the slope up 1 over 2. Okay. Now, let's have just a little side conversation on this. We've talked about a lot of transformations. We did transformations with piecewise. We've done transformations with absolute value. We did them with quadratics. All right. What is the parent function for a line? That's the easiest line we could have. Okay? So that's the parent function of a line. What transformations did I do to get this one? I went up 3. We see the up 3. We're supposed to be at 0, 0, but what do? We moved it up 3. Make sense? Okay? What is the 1/2? It's I would call it a vertical compression. Here's where my parentheses would be. Okay? There's where my parentheses would be. Now, so that would be, I would probably call that a vertical compression. Now, why would I do that? Well, my normal slope for the parent function is what? Up 1 over 1. But on this one, I'm doing what? Up 1 over 2. I pressed it down. I'm not going as fast. Okay? Now, let me ask this question. Have you seen a line be written like this before? Close, right? What is that format right there? What form of a line is that? It's kind of in between. All right? Why do I say that? because normally we're used to seeing this over here, and we're normally used to seeing it as y minus 1 equals m times x minus 2. All right, or excuse me, 3 minus 2, all right? And so if I have it written like this is point slope form, okay? Point slope form, what would the x minus 2 mean here? What transformation? I've moved it right too. See, it's in parentheses there, okay? If I move the 1 over like I had there, then that would be up 1. So I moved it right 2 and up 1, and so that's my transformation, okay? So even though lines are easier, and we normally don't talk about transformations in them, we still can do that, okay? All right, I want you to graph one more for me. All right, I want you to do on a third graph. All right, here you go. I want you to do h of x. H of x equals 2x squared plus 1. I want you to go graph that one. H of x equals 2x squared plus 1. We'll graph that on a third graph. List your transformations if it helps you. Oh my gosh, you're an idiot. All right. So what transformations do you see in this one? There's a vertical stretch. Vertical stretch by 2. What else? Up 1. By the way, what is the shape of this graph? It is a parabola. That is correct. Okay? So my parabola normally starts at 0, 0. But I'm going to go up 1. So there's my vertex right there. I moved it up 1. It's a vertical stretch, so my pattern has changed. What is the pattern for a parabola? 1, 1, 2, 4, 3, 9. Good. 1, 1, 2, 4, 3, 9. But I'm not going to graph that pattern because it's changed. Instead of going over 1, up 1, I'm going to go over 1, up 2. Because my vertical stretch. So 1, up 2. Instead of going over 2, up 4, I'm going to go 8. That's correct. I got a vertical stretch, so I'm going to go over 2 and up 8. By the way, all these, if it helps you, these are all 10 by 10s. All right? 10 negatives, 10 positives on both directions, so it's easy to count. Okay? So here is that graph. Okay? Everybody all right with that? So we're looking at a lot of the things that we talked about with our parent functions and our transformations. Now, here's what I'd like you to do. Take this page that we worked on a while ago, just flip it over. Let's go to the blank back side. All right.
That's gotta be fake.
Alright. I want you to put that table on the back side. Okay? Alright. Let's put this table on the back of your page here. Yep, just turn it over. You got a blank spot back there. Put that back there.
Yeah.
Get too excited.
Alright, so here's what I'd like for you to do. Alright? I want you to take a little time. We've talked about compositions. I've put 4 problems up here. Using your table, I want you to go find me these 4 answers. So there's 4 problems right there. Give you a little time there. Use your table. And let's find those values. F of G of 3, G of F of -1, G of G of 3, and F of 9. Use your table. Go find those values.
I went towards you.
No.
He said that. Oh, that's really. No, it is. It is. Oh, I messed up. Wait.
Okay, so that's, what function is that saying? Okay, so what's G of 3?
There's no 3 on there. There's no 3.
There's a, no, look at X. When X equals 3, what is G of
That's
X?
not for G of X. Wait, when X is 3. Look. X is 3. G is 7. So that means 7.
Yeah.
And then when G is 6. Because when G is of X is 7, then that's F of X is 6. But that's not equation.
What?
No. No, we're talking about this one. We're talking about the very first one. Yes, G of G. No, it's G of 3. No, those are, I'm talking about G of G. Oh, G of 3. So when X is 3, G is 7. No, it doesn't say that. It doesn't say that one is 7. It doesn't say. It doesn't say.
What do you say?
When G is
Bro, if you don't want to use that, well, that should be a problem.
I'm saying it's 6.
Okay, I see where you went from. So, okay, so you know that G is 3. So, what you're doing is you're saying, okay, so G of 3.
So that F of G of
let's plug in this value into f of g. So,
That's the thing, bro. I heard the people behind us. Talking about the one about the total question.
Wait, we're putting 7
We got that
there?
yes.
So then it'll be.
X is 3. The G of G
F of negative would be f of 7. Because g
Oh,
is
we're not
inside.
done?
I don't know, too. You got this.
That's not.
Negative, then it'd be f of 7. What's f of 7?
See, that's a good question.
All right.
I can figure it out.
Anybody have, the first one that you want to put on the board? Everybody have the first one, want to come put it on the board? Come on, Wayne. Alright,
What do I put on the board?
just walk through how to do the first one and put the answer up there.
Where's the
You could just use your finger, actually.
Okay.
Go for it.
So for the first one, you see that this is just equal to f of g of 3. That's what it's saying. And we know that g of 3, if you look at 3, go down to the g of x table, that's 7. So g of 3 equals 7. So then you plug in this value into like the function that's inside f of x. So this is equal to f of 7. And if we look at where 7 is in the x table, we go down to f of x, we see that f of 7 equals -2. So this equals -2.
Very nice. Good. That was number 2. Alright. Somebody want to do a different one? Anybody else want to try one?
Who volunteer? People who volunteer.
If you volunteer, you have to do one yourself. Come on, Emma.
Yes. No, Mario, sit your
Mario,
butt
I'll
back
let you
down.
do it
It's
yourself.
Emma's turn.
Oh, Emma, okay, thank you.
What did I just say?
Okay. Wait, I grab one of these.
Yeah, that or you can use your finger, either way.
I'll use one.
Wait.
Yep.
Let's do this one. Okay, so I look at this first and I see that when x is 3, g is at 7, so, it's literally the same one. Okay, well, he wrote it down right here. And then I go back and plug in the 7, and I see when x is 7, that this g is 0, so that means your answer will be 0.
That is correct. Good. Alright, very nice. Somebody else want to do that one? Anybody else? No other takers?
Pick and choose, pick and choose.
Alright. So talk me through this one. What does this mean? What do I do with the -1? I put it into f first.
Yeah.
Okay? So f of 1 is 9. I take the 9 and I put it into g and I get -4.
That's totally what I got.
Okay? Okay with that? Alright. Last one, I take f of 9. F of 9 is -1. Take the -1, plug it back in, and get f again, and it happens to be +9.
None of them were feminine. Well, actually.
Alright?
Two.
Questions about that so far? Now, here's what I'd like for you to do. Okay? Go back to your graph. Go back to your graphs that we had, that we just made. We just graphed f of x, it was absolute value. We just graphed g of x, it was a line. And we graphed h of x, and it was this parabola. So here's what I'd like for you to do. I'm going to give you another little shot at this. I want you to go, and I want you to find me f of g of 0. Okay? Using these graphs that we just graphed. Okay? So using not the table we had, but the graphs. So do f of g of 0. Do h of f of 2. And I want you to do g of h of 1. Okay? I want you to do those 3. Okay? So using the graphs that we graphed, actually you have equations as well, but I want you to see if you can go answer those 3 questions. Don't use the table. Don't use the table, you're using the graphs that we have on the graph paper. Yep. All right, do it. Focus on your paper. Let's go. F of G of 0.
Second one. Why do you think everything is 7?
That is not okay.
Sorry,
How do you grab two?
Okay, you don't grab, you say,
Calculated it out.
Those are things that you're supposed to solve. Those are things that you're supposed to like. Oh. Technically, you don't solve that kind of problem. You just simplify.
What's 1/2 of 5? 2.5.
All right. Let me work the first one with you, so catch up with you, see how you've done. All right. So I have F of G of 0. Okay. F of G of 0. So this is my G graph. So F of G of 0. So at 0, I'm going to go to my graph and I get 3. So I go to my graph and I get 3. I'm going to take that 3 and I'm going to take it to the F equation. So the F equation was here. And I'm going to go look on my graph where X is 3, my Y value is 2. So the answer should be 2 here. So F of G of 0 should be 2. Now, there's another way I could have worked this. Anybody work it a different way? Did I have to use my graphs in this case? Could I have used my equations? And so if I did this, I could have put 0 in here. Could have put 0 right there. Half of 0 is 0 plus 3 is that same 3. I can take that 3, I can plug it in here. 3 plus 2 is 5. Absolute value of 5 is still 5. Minus 3 is 2. So I got it that way. So now that we walked through 1, go try the other 2 if you haven't done so. H of F of 2 and G of H of 1. Did anybody come up with a value for H of F of 2? Anybody come up with an answer? H of f of 2. Got 3? Okay. Let's take a look. So I'm going to go f of 2. So I'm going to go over to my f graph. Here's my f graph right here. F of x. So if I do that, I get 1 as the answer. All right. I'm going to take that 1 and I'm going to plug it into, what was it, h? Is that correct? Yep. I'm plugging into h, which is this one. So I'm going to plug the 1 in, and it gives me that point right there, which is 3. 3 is the correct answer. All right. Could we have plugged it into the equations if we wanted to? Yes. All right. Needed to see it again. That one. So we did h of f of 2. So we went to f, which was this one. Okay. X is 2, y is 1. So I'm going to take the 1. I'm going to take 1, and it's now my new x for h. So now I go to h, and when h is 1, y is 3. Okay? So how about the last one? How about g of h of 1? H of 1 is 3. Okay? Take the 3, go plug it into the g of x. The g of x is here. And if I go to 3, then I'm right here. I'm kind of in between numbers. What is that number? 4.5. Okay? Could I plug it into the equation if I needed to?
Yeah.
Sure. All right. I know that since I'm going up 1 and over 2, that I'm going up a half each time. So I have that. Now, I want you to try this one real quick. We got a couple more problems. Hang with me. All right. I want you to try that one right there. H of g of x. H of g of x. Now, this one's not going to be a single value. We're going to write an expression. Okay, so h of g of x. All right. If you know what you're doing, I think you've got it already. All right. If you're not sure, let's talk about it. And so there's no values here. There's no x's or y's. We're going to take and we're plugging an equation into another equation. I'm taking g, which this is g. What am I going to do with that? I'm plugging it into here. So my h of g of x is going to be 2, parenthesis, 1/2 x plus 3. We're going to square it, because there's a square, plus 1. All right? I'm okay with that. You've made the equation. All right? Now, the hard thing about this is I could multiply it out. I could do 1/2 x plus 3 times 1/2 x plus 3. But because of the fraction, that would probably be a little bit more difficult here. Okay? We could still do that. But that's the representation I would have. Now, I want you using, there's 2 more graphs left on this page. All right? So, here's, yeah, you may have 3 left. That's fine. All right? I want you to take f of x, which was our first one. F of x was the absolute value. And I want you to graph me the absolute value of f of x. So use one of the additional graphs there, and to do absolute value of f of x. And on one of your other graphs, I want you to do me the graph of g of the absolute value of x. Okay?
I hate my apps. My apps are ugly.
So I want you to try to graph these two right here. Absolute value of f of x.
Log date does counter, because your troops can either be logged, you got the princess, Gargoyle,
Yeah, it should look something like this.
Your absolute value of e for this graph right there.
Jays don't have that. Wait a second.
This is f of x. So do your absolute value of that graph.
Walk in. Okay.
you don't have Evo Inferno, or Evo Baby Dragon.
Wait, I know what it is. This is the way she
I have to watch the bit for.
Whatever Luke gets positive, so move it up.
Absolute value of x. Oh, you're talking about, you're not talking about
That's
absolute
in
value.
Ganon, that's it. I can grab that. I face them earlier. Oh my god.
Wait, so it has to be positive.
What did you do? It doesn't look like you're in the movie.
There we go. Yeah,
If you watch my shirt, like my shirt.
It's like right here.
We've got a lot of talking going on. One of the reasons I feel like you're missing some of this is because I don't think you're completely focused in. This is f of x right here, alright? I asked you on this one, by the way, when I do ask you to go try this, I need you to do that, not just sit there and talk until I put it up on the board. That's not how it works. You've got to attempt. Attempt and get it right is good. Attempting and failing is fine. You've got to learn what's going on. You got to give it a chance. Some of you are not even trying. All right? So I asked you to do the absolute value of f of x. That's the graph that we had originally. So if I applied the absolute value to this, what happens? The positives are still positive. Good. This right here is positive, it stays positive. That side right there is positive, it stays positive. So that part of the graph stays the same.
Excuse me?
Yes.
Do you have Kindle?
Yes.
Being checked out.
Okay. All right. Now, what happens to this? It becomes positive. It reflects. So this goes here. So I end up with the graph that looks like that. So the absolute value of f of x would be the green right there. Okay? Everybody all right with that? Good? Now, the second one that I asked you to do. By the way, the purple would not be part of my graph. That was just my original. It got flipped up. All right? The second part I asked you to do was to take g of x and to do the absolute value of the x's. So g of x was this line right here. So here is g of x. And I asked you on g of x to do the absolute value of x. So I asked that transformation there. Okay? Now, on this transformation, how do we do this one? How is this one different? Yes, sir?
You put the, so for 1/2 x plus 3, you put the absolute value around the x. So it would be all the positive x values are the same, and then once the x values turn negative, it's just a reflection across the
Okay.
y-axis.
So those stay the same. The x's, the positive x's stay positive x's, they don't change. The negative x's turn to positive x's and they look just like that. So now we have the reflection. There is a reflection over here. So the blue is a line. Okay? The right side stayed the same because those are positive x's. The negative x's acted like the positive ones. So I get a reflection. What graph does that look like? It looks like absolute value. Okay? Looks like absolute value. Okay? All right. I got one last thing for you today. All right? Tis the season for holidays, which means tis the season for my wife to do lots of shopping. All right? She likes to spend money. All right? And so she's buying some Christmas gifts and such. My daughter has found something that she likes. It is $50. All right? My wife has 2 coupons. All right? This store that she goes to a lot will accept both coupons. All right? The 2 coupons she has a $10 off coupon. She has a 20% off coupon. Okay? She's got those 2 coupons. The person behind the counter is not very bright, all right? And so my wife wants to make sure that we get as much money off as we can. So she's going to hand the coupons in a certain order so that they get applied in a certain way, all right? Which one does she want to hand first? Does she want to give the $10 off and then give the 20%? Or give the 20% and then the $10 off? So what I'd like for you to do is I want you to find me the price for the $50 item both ways. If I do one way versus doing the other way. So see which way is better.
Oh my goodness, look at 30.
What's 10%?
$32 if you do 10 and then 20.
That's 32. First one's 32. The first one is what the heck? 30. I know.
But if you go 20% then 10, you're marking off $10. And then you mark off.
Don't take it cheap.
Like, let's say,
Why does that look like
you know that 20%, you know that 20% of 40 is less than 1%, right?
Yeah.
Okay, so you're gonna apply the $10, like the $10 discount either way.
Here you go. Let's talk about it real quick because we're just about out of time. Which one's better? All right, yes, ma'am?
Give the $10 off first.
$10 off first and then do 20.
Yes.
So if you do $10 off first, then I still owe $40. And then what is 20% of 40? $8. So I would subtract 8. By the way, 10% of anything is pretty easy to find. 10% of 40 would be $4. Therefore, 20% would be 4 plus 4, which would be 8. So I'm going to pay $32 there. All right? Now, anybody think the other way?
Me.
What's 20% off of 50? That's $10. 20% off is 10. Take the additional 10 off. Now, Is it a big difference?
Yes.
No, but I want my $2.
It is.
Now,
I don't have that.
here's the thing, one last thing.
I don't get it.
If this is f of x, and this was g of x, then the correct way of doing this would be f of g of x. No, hold on to it. We'll turn it on Friday. Go with our homework set. All right, we're out of time, so I need to pack up.
I'm not.